The image that will stay with me is not the missile trails. It is a single frame from a thermal feed at an Iron Dome battery north of Beersheba, taken at 4 minutes past 3 in the morning, showing a battery commander standing outside his command vehicle with his hands at his sides. He was not on the radio. He was not directing his crew. He was looking up. For perhaps 11 seconds, a man whose entire professional life had been built around the discipline of engagement decisions stood still and watched, because the picture above him had exceeded the framework his training provided for interpreting it. He went back inside the vehicle. He resumed his duties. The battery continued to engage. But that pause, multiplied across every battery commander in the country that night, is the variable that the after-action reports will struggle to quantify and the variable that mattered most. This is not a story about whether Israeli air defense worked or failed. The honest answer to that question is that it did both, in different places, at different moments, against different threat types. And the binary framing the public will reach for is going to obscure what actually happened. This is a story about what happens when an air defense architecture built over decades around a particular relationship between threat volume and interceptor inventory encounters an attacker who has decided to break that relationship deliberately and is willing to absorb the cost of doing so. I have spent a long time studying the Israeli air defense system, and I want to be direct with you about something at the start. Iron Dome, David's Sling, and Arrow are among the most operationally tested and professionally operated air defense systems in the world. The reason this night placed them under the pressure it did was not that they had been neglected. It was that the threat had been designed specifically to exploit the seams between the layers that made them effective in the first place. Let me explain what I mean by that. Because the seams are where the entire engagement turned. The Israeli air defense architecture is built on a principle of layered specialization. Each layer is optimized for a particular threat profile. Iron Dome handles short-range rockets and artillery. David's Sling addresses medium-range threats. Arrow engages ballistic threats at altitude and at range. This specialization is what makes the architecture efficient under normal threat conditions, because each layer is doing what it was designed to do, and the interceptor inventories of each layer are sized to the threat volume each layer is expected to encounter. The architecture is a watchmaker's design. Every component has a role, and the roles fit together with precision. The vulnerability of a watchmaker's design is that it depends on the threat behaving the way the design assumed it would. If the threat arrives in the volumes and combinations the layers were sized for, the architecture performs beautifully. If the threat arrives in volumes that force multiple layers to operate at maximum capacity simultaneously, while combining threat types in ways that prevent any single layer from absorbing the load alone, the precision of the design begins to work against it. The interceptor inventories that were sized for specialized roles are being expended in parallel rather than in sequence. The decision architecture that was built around predictable handoffs between layers is being asked to coordinate handoffs at a tempo it was not exercised against. And the reserve depth of each layer is being consumed by a threat geometry the layer was not optimized to defeat. Iran's planners understood this, and the strike package they assembled was built around exploiting it. The 1800 ballistic missiles did not arrive as a single mass. They arrived in 3 overlapping waves, separated by intervals calibrated to maximize the pressure on Arrow's engagement cycle. The first wave, roughly 600 systems, was launched from dispersed positions across western Iran in a window of approximately 11 minutes. The second wave, slightly larger, was launched from positions further south, including locations inside Yemen that had been prepositioned for exactly this purpose. The third wave, smaller in number, but including a higher proportion of systems with terminal maneuvering capability, was launched once the first two waves had begun consuming Arrow's interceptor inventory and forcing the system into engagement decisions about which incoming tracks justified expenditure and which did not. The 900 Shahed drones were not the main effort. They were the discrimination problem. Launched in staggered streams from multiple azimuths, they served two functions simultaneously. They populated the radar picture with a volume of low-cost, low-speed tracks that the lower layers of the defensive architecture had to address, because ignoring them was not an option and engaging them was an expenditure problem. And they masked the approach geometries of the cruise missiles and standoff systems that were mixed into the same streams at intervals designed to exploit the discrimination delay each Shahed wave introduced. A radar operator looking at a picture saturated with slow movers is an operator whose attention is being managed by the attacker, and the cruise missiles inside that picture were arriving at the seams between Iron Dome and David's Sling at exactly the moments the operator's attention was being consumed elsewhere. This is the doctrinal heart of what Iran was attempting, and I want to name it clearly because it will be the model studied by every adversary watching this engagement. The strike package was not designed to defeat Israeli air defense. The strike package was designed to force Israeli air defense to defeat itself by expending its inventory against the wrong portions of the threat at the wrong moments. This is a different objective than penetration, and it requires a different metric for assessing whether it succeeded. The question is not how many warheads reached their targets. The question is what condition the defensive inventory was in when the sun came up, and what condition the decision architecture inside the air defense network was in by the time the third wave was being processed. The condition was not good. I will be specific. By approximately the 70th minute of the engagement, Arrow batteries across the central and southern sectors had expended interceptors at rates that the original inventory model had treated as a worst-case planning figure for an entire month. The replenishment timelines for those interceptors are measured in weeks and months, not hours, because the production base for advanced ballistic interceptors is not a base that surges easily. The batteries were still operational. The crews were still functioning. But the inventory that gave the system its real meaning was being consumed at a rate that introduced a new variable into every subsequent engagement decision. The doctrine of engaging every credible ballistic threat with the layered redundancy the system was designed to provide was no longer affordable in the moment. The commanders were being forced into single-shot engagements where doctrine called for multiple, and single-shot engagement probability against maneuvering terminal phase warheads is meaningfully lower than the probability the architecture was designed around. This is what overload looks like at the operational level. It is not the cinematic image of a battery being destroyed or a radar going dark. It is the quieter and more consequential image of an engagement protocol being modified mid-engagement because the inventory will not support the protocol as written. Every modification introduces a small increase in the probability that a given incoming threat reaches its target. Multiplied across hundreds of engagements, across all three layers, across the duration of the attack, those small increases compound into a different outcome than the architecture's design parameters would have predicted. The principle I want serious students to extract from this is one I have stated before in different contexts, and it applies here with particular force. An air defense system derives its power from two things working together: inventory and tempo. Remove either one, and the other is insufficient. A system with deep inventory and slow decision tempo will be saturated by a fast attacker who outpaces the engagement cycle. A system with fast tempo and shallow inventory will exhaust itself before the attack is complete. The Israeli architecture had both, in measures that under most threat conditions are more than adequate. What Iran did was design a strike package that put both variables under simultaneous pressure for long enough that the relationship between them began to fail. Let me describe what was happening at the lower layers, because the Iron Dome and David's Sling story that night is different from the Arrow story and deserves to be told on its own terms. The Shahed streams arriving from the eastern and northern approaches were not the technical problem they would have been a decade ago. The systems are slow. Their flight profiles are predictable. Iron Dome operators have engaged this class of threat thousands of times in this campaign, and the engagement geometry is well understood. The problem was not the individual track. The problem was the cumulative track count sustained across hours, while higher-tier threats were simultaneously consuming the attention of the same coordination cells that had to authorize Iron Dome engagement priorities. Iron Dome's inventory had been managed across this campaign with extraordinary discipline. The replenishment lines have been operating at high tempo for months. The interceptor stocks at most batteries were at the upper end of their planned levels when this engagement began. None of that prevented the situation in which, by hour 3, battery commanders across the central sector were receiving engagement priority adjustments that reflected a system-wide inventory awareness that had not been part of the routine engagement decision process. The system was no longer engaging every credible threat with the doctrine it had refined over years. It was triaging in real time across a track picture that exceeded the routine doctrinal envelope. Triage is not failure. It is the consequence of being asked to operate beyond the range the doctrine was written for, and it produces outcomes that are different from the outcomes the doctrine was validated against. Now, the warheads that reach their targets. The public discussion is going to focus on this, and I want to address it carefully, because the focus will be misleading if it is treated in isolation. A meaningful number of ballistic warheads reached the central Israeli landmass that night. The damage at the airbase in the south was operationally significant, including damage to runway surfaces that will require repair timelines measured in days rather than hours, and damage to maintenance facilities whose contents cannot be quickly replaced. 2 strikes in the greater Tel Aviv area produced civilian casualty events whose human cost will be central to how this engagement is remembered. A cruise missile that penetrated the seam between layers in the northern sector reached a fuel storage facility whose secondary fires were visible across half the country. None of these are minor events. Every one of them represents a failure of a specific defensive engagement that the architecture, under different conditions, would have been expected to win. But the strategic question is not which individual engagements were lost. The strategic question is what the engagement as a whole revealed about the relationship between the defensive architecture and the threat it now has to plan against. And the answer is that the relationship has shifted. The assumption that the Israeli air defense architecture could absorb a strike of this magnitude without operating outside its designed envelope has been tested and found, in important respects, to be optimistic. The architecture absorbed the strike. It did not collapse. The country did not become indefensible. The casualty figures, while painful, are far lower than they would have been against a defense of any lesser sophistication. All of that is true and worth stating clearly. What is also true is that the inventory consumed that night cannot be replaced inside the window in which Iran or any other adversary might choose to repeat the attempt. And the doctrine that had been refined against smaller engagements is now operating in territory it had not previously been required to occupy. The cruel geometry the Israeli command faces in the days following this engagement is not the geometry of the night itself. It is the geometry of what comes next. Replenish the inventory at the maximum sustainable rate and accept that the rate is not fast enough to return the architecture to its pre-engagement depth within any politically acceptable timeline. Adjust the engagement doctrine to extend the inventory by accepting higher single-shot risk on individual threats, which preserves capacity but increases the consequence of any future engagement. Pursue offensive options to address the launch infrastructure that produced the strike, which carries its own risks and timelines and may not be available at the scale the defensive problem demands. None of these options restores what was actually consumed, which was the comfortable margin between defensive capacity and threat volume that had given the architecture its strategic credibility for years. I want to give the Iranian planners their due here, and this is uncomfortable for me to say because the human cost of what they did was significant, and the strategic recklessness of choosing this path will shape regional dynamics for a generation. But the planning that went into the strike package was not amateurish. It was, in important respects, sophisticated. The understanding of Israeli air defense layering reflected a serious study of how the architecture was built and where its seams were located. The decision to combine ballistic and drone threats in the specific ratios and timings used reflected an understanding of the discrimination problem and the inventory problem as related rather than separate variables. The prepositioning of launch infrastructure across multiple geographies, including the use of Yemeni positions to extend the threat geometry beyond what a single azimuth defense could efficiently address, reflected the kind of operational planning that takes months to develop and cannot be improvised. This was not a desperate lashing out. This was a deliberate test of whether a saturation strike of this scale could be made survivable for the attacker and decisive against the defender. The first half of that question, Iran has now demonstrated, can be answered yes. The second half remains open, and the answer to it will depend on what happens in the weeks that follow rather than on the engagement itself. The doctrinal lesson that will be studied in every air defense command in the world for the next decade is not that Israeli air defense is inadequate. It is the opposite. It is that even an air defense architecture of this quality, operated by crews of this discipline, supported by an industrial base of this responsiveness, can be pushed into an operating envelope outside its design parameters by an adversary willing to accept the cost of generating mass at the volumes required. The implication for every other country that depends on layered air defense is that the assumptions underwriting their own architectures need to be examined against this new benchmark. If Israel can be pushed into triage by an 1,800 missile and 900 drone strike, what volume would push your network there? When was the inventory model last revised against a threat profile that included combined ballistic and drone saturation at scales this campaign has now demonstrated are achievable? When was the decision architecture exercised against a track count of this density? And if the answer to any of these questions is that the assessment has not been done recently, then the architecture in question is operating on assumptions that this engagement has just rendered obsolete. The deepest assumption that died that night was not about hardware. It was about scale. For most of the modern history of air defense, the assumption has been that an attacker faces inherent cost constraints on the volume of precision strike systems he can generate and employ in a single engagement. That constraint is what made layered defense viable because the inventory required to defeat the expected volume was finite and affordable. What Iran demonstrated, and what every adversary watching this engagement has now taken notes on, is that the constraint has shifted. The cost of generating mass has fallen. The willingness to accept attritional losses among the attacking systems has risen, and the combinations of cheap and expensive systems that can be employed together have multiplied. The defender's inventory math has not improved at the same rate. The gap between what attackers can now afford to throw and what defenders can affordably intercept has narrowed, in some configurations, to the point where the architecture's economic sustainability is itself a strategic variable. The morning after this engagement, the repair crews are at work on the runways. The civil defense services are still processing the casualty events. The interceptor production lines are running at maximum tempo and will continue to do so for the foreseeable future. The crews at the batteries are debriefing engagement after engagement, refining the data, updating the procedures. The work of recovery is professional and ongoing and will produce the lessons that should be produced. None of that recovery work changes the fact that the architecture is now operating on the other side of a threshold it had not previously crossed, and that the threshold cannot be uncrossed by any amount of replenishment or analysis. The next time a strike of this magnitude is contemplated against this country or any other, the planners on both sides will be reasoning from this engagement rather than from any of the engagements that preceded it. The battery commander outside Beersheba is still on duty this morning. He has not spoken publicly about the 11 seconds when he stood outside his vehicle and looked up at a sky that exceeded his training. He will probably never speak about it, but the question his pause raises is the question every air defense officer in every country should be sitting with this morning. When the picture above you exceeds the framework your doctrine provides for interpreting it, what does your training tell you to do? And if your training does not have an answer for that moment, how confident are you that your country's defense rests on something more durable than the hope that the moment will not arrive?